Okay, today we are talking about exponential story problems. So exponential story problems come in two different varieties. We've got our growth and we've got our decay. And our formula we use is slightly different depending on which it is. So if we have a growth equation, that means that our value is getting more and more over time. So if it's growth, so if it is growing over time, the formula we're going to use for that one would be our starting amount, which I'll just call A here. So that's our starting amount. Okay. And then we multiply that by 1 plus our R, or rate, in which it is increasing by. So this is usually some kind of percentage or whatever. And then we raise that to the power of t, which stands for time. Okay, so that's the formula we're going to use for growth. You take your starting amount, multiply by 1 plus r, or rate, and then you raise that to the power of whatever time we're talking about. Okay, if it's decay, so that means it is going down over time or decreasing in value. Our formula is going to be pretty much the same except for one little thing. So it's still going to be the starting amount being multiplied by 1, but instead of adding our rate, we're going to subtract our rate and then raise it to t. Okay, so that's basically the formulas you're going to set up here when it asks for the function that represents a situation. It's asking you to set this up. So let's look at these and let's see if we can do a couple examples with you guys here. So, first example, number 1. You buy a house for $130,000. It appreciates 6% per year. How much is it worth in 10 years? So appreciates, that means that it's growing or getting bigger. So if it's appreciating 6% per year, it's growing at 6% each year. So this is going to be a growth problem. It is growing over time. Okay, our initial amount, we initially paid $130,000 for it. So our initial amount is $130,000. Our percent that it's growing or decaying, it's growing by, so our growth rate is 6%. So it's growing 6% each year. So if it's growing at 6% a year, it wants me to write that as a percent and a decimal. So to find the decimal of a percent, remember you just take the decimal and go over 2 spots. So if I go over 2 spots from 6%, I'm going to be at 0.06. So 0.06. So then to set up our function here, it's going to be our amount is 130,000. Okay, and then we multiply by that 1 plus our percent, but we want it as the decimal. So it's going up by 0.06, so 1 plus 0.06. And then we raise that to the power of t. In this case, well, I'll just put it here, so t. Okay. Now to answer the question, it wants to know how much it's worth in 10 years. So I would rewrite this equation. So 130,000 times 1 plus 0.06. 1 plus 0.06 is 1.06. And then it wants to know what it is in 10 years. So I'm going to raise to the power of 10. So then when I do this, I take a calculator and I go 1.06 and I have it raised to an exponent, and I have it multiplied with a number. Now I'm going to follow my order operations. Remember PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. I follow the order operations, so I'm going to raise it to the exponent first, then multiply. So raise it to the power of 10. That gives me 1.79 blah, blah, blah. So then I take that number and I multiply that by 130,000. So multiply that by 130,000, and I get $232,810. So house increased by a little over $100,000 in 10 years. Whoops, 232,810. Okay, that's a 3, and that's a 2. Yeah. Okay. So then let's look at our next problem. So we solved that one. Let's look at the next one. Mr. MD is losing 20% of his hair each year. If he currently has 1,546 hairs on his head, about how many hairs will he have left after 10 years? Now, it's kind of sad that he's gotten to the point that he's counting his hairs, but, to each their own, I guess. But he's losing hair. That means it is decaying over time, right? So I'm going to have to use the decay formula, which, again, the only difference is instead of adding the rate, I subtract the rate. So this is a decay. And the initial amount, the poor guy only has 1,546 hairs left. Okay? And then as it decays, he loses 20% of his hair each year. So 20%. And as a decimal, again, you move the decimal spot over 2 to get it as a decimal. So it'll be 0.2. Okay? Then, to write that as a function, I'm going to have the starting amount, 1,546, be multiplied by 1 minus 0.2, and that's all going to raise to the t power. Okay, and this wants me to figure out what it is after 10 years, so to do the answer, it'd be 1,546, and then 1 minus 0.2 is going to be 0.8, being raised to the 10 year. So I'm going to take 0.8, raise it to 10, which is 0.107, blah, blah, blah. And then I take that number and multiply by the starting amount, so multiply by 1,546. And after 10 years, he is left with 166 hairs on his head. Okay? That's all he has left. Poor guy. He's probably shaving his head at that point because he doesn't really have anything to really do anything with up there. All right, so that is the exponential story problems there. Again, you just use these formulas to set up the functions, and they kind of do themselves when you do it. You just raise it to the exponent first and then multiply. Okie dokie.